Non-AP Micro FRQ number 2 today. This is an indirect tax question. They want us to calculate the producer surplus. S denotes supply, D denotes demand, easy. All right, to know producer surplus, this is before the tax. So we know that before there was a tax, our price was 5, our quantity demand was 90. So we're really looking for this area for the triangle below the price. Remember, producer surplus is everything below the price but above the supply curve. Producer surplus is the idea that all the suppliers on this section of the curve here would have been willing to offer or sell this good for a cheaper price, but they don't have to. They can actually sell it for $5. So this is sort of all of their producer surplus. Obviously, the top area up here is consumer surplus, but they want us to calculate the producer surplus. So we can see that the height is from 2 to 5, and then the base is from 0 to 90. So it is 1/2 base times height, just the area of a triangle. If our height is 3, and this is 90, 3 times 90, what is that, 270? And then just divide that by 2. So is it 135? I think that's right, 135. All right, now assume a per unit tax of $2. College Board loves a $2 tax. Is imposed, meaning that now the tax is put upon this good, whose impact is shown in the graph above. Anytime we have a tax, it's going to shift supply to the left. They want us to calculate the tax revenue. Now, recognize here that the distance between these two, the vertical distance between these two supply curves, actually shows the price of our tax. So we could have shown the distance here. The vertical distance between those two curves is the amount of tax. We could have shown it right there. That vertical distance is the amount of tax, but we're going to show it right there. Notice that vertical distance between these two supply curves shows us the amount of tax. So the amount of tax between 4 and 6 is $2. They've already told us that, but it's nice to be able to see it. They want us to calculate the amount of tax revenue. Recognize that these are always asked pretty much the same way. And that we're always going to find our new price after the tax. This is the price that the buyer pays, the price the buyer would now pay. Obviously, the amount of tax goes to the government, and the $4 would be what the seller would receive or put in his pocket. All right, and that should make sense. If I sell a good for $6 and the government takes $2 away from it, now I can put $4 in my pocket. That should make sense. All right, let's go back. I calculate the amount of tax revenue. Recognize that if this is the amount of tax, it is on the quantity of goods sold after the tax. So it's just $2 times 60. We could have said tax times the quantity after the tax, something like that. We could have said 6 minus 4, which is the same thing as giving us 2, times QT, or the quantity after the tax, or in this case, 60. Anyway, our tax revenue is going to be 120. The after-tax price that the seller now keeps, the price. For some reason, this language causes people some issues. What is the after-tax price that the seller now keeps? It is just the $4 there. Per unit is what they probably should have said. That would have made it a little bit clearer. What is the after-tax price that the seller keeps per unit? That should make sense. Calculate the producer surplus after the tax. Now, recognize that different teachers teach this in different ways. Where is the producer surplus? Now, if I had to be exact about it, I'd say here's our new price at $6. So we know that producer surplus is everything below the price but above the supply curve. Here's our new supply curve. So I would say this is our new producer surplus. But lots of times teachers don't like students because this is also the government revenue wedge or the tax wedge. So lots of times they teach you that you can use this area. Now, these two lines are parallel, so this area right here should have the same calculations as this right here. So don't get hung up on which one your teacher wants you to use. If I had to choose one specifically, I would choose the upper producer surplus, but both of them are going to calculated give you the exact same number. So it looks like our height is 2 and our quantity or width there is 60. So 2 times 60, is that right? 2 times 60 would be 120 and divided by 2 or times divided by 2. So 60. All right, is the demand price elastic, inelastic, or unit elastic between the prices of 5 and 6? Let's get rid of some of this over here. Now, two ways to do this. I would probably opt for what we call the total revenue test because the numbers are easy. Or you could find the PED value. We're going to do both really quickly. The total revenue test is simply, we know total revenue is just price times quantity. That gives me my total revenue. It looks like at a price of 5, there was 90 sold. Total revenue would have been 450. And then a price of 6, there was 60 sold. So total revenue was 360. What we can see here is when the price went from 5 to 6, when the price went up, that total revenue went down. Now, there's a lovely little graph that's helpful for this, and I draw it in the margins every time I'm working on any of these total revenue, price, elasticity of demand questions. Here's my total revenue curve. Just recognize it's just a semicircle. Right where it maximizes there, at the top of total revenue, I go straight up. And where I hit the demand curve, I'm just going to call that unit elastic. Remember, this is just a model so that you can answer these questions and sort of see what's going on. The bottom section of the demand curve is going to be inelastic. The upward section is going to be elastic. Now, price is here. Recognize that when the price went up in our scenario, total revenue went down. The only section of the demand curve that works in is the elastic section. If I'm on the demand curve in the elastic section and I raise my price goes up. Recognize that this model just shows that my total revenue is going to go down. And this should make sense that in the elastics, if your demand for your good is elastic and you raise your price, you lose a lot of your customers. So the understanding here is that you lose a lot more customers than by the percentage you raise your price, so your total revenue is going to go down. So we would say that it is relatively elastic, and we would explain either using this total revenue test by just saying that when the price goes up, total revenue went down, therefore we must have been in the elastic section of our demand curve. Understand how this model works too. It's helpful. If we had risen or raised our price, if our price had risen and our total revenue went up, we would have known immediately that we must have been in the inelastic section of our curve. This works the other way too. If price went down and the demand is inelastic for our good, total revenue should have gone down also. If we're in the elastic section and we lower our price, we should recognize that our total revenue would have gone up. There's a lot of these kinds of questions, and it's very easy to use a total revenue test. And then this little model here to make sure that we're thinking about it in the right way. We also could have done the PED value. We know it's a percentage change in quantity demand over a percentage change in price. It looks like our quantity demand went down from 90 to 60. So that is 0.33 percent change decrease, but remember PED's absolute value, so we don't have to worry about. We're always going to get a decrease in demand when the price goes up. It looks like our price went from 5 to 6. So that's 1/5, we added 1 to our 5 there. I'm not sure if I'm saying that right, but the idea is it's 0.20 here. We can see that these numbers are going to give us, obviously 0.2 goes into 0.33 more than 1 times. So our PED value would be greater than 1. Therefore, we know that it's elastic. If my math skills were better, I would do that for you. All right. We can see, and we would just explain it by using our numbers and showing that PED value was greater than 1. Therefore, it was elastic. Or we can do the total revenue test easy. We could also have done the formula, P2 minus P1 divided by P1 over QD2 minus QD1 divided by QD1. This formula works also just as well. You just have to know if you can. If you're not a math guy like me, I'm not a math guy. I'm an econ guy. Sometimes those two blend together, sometimes they don't. But understand that here we started at a 5, so that would have been our P1, and obviously 90 was our QD1. We went to 6, that would have been P2, and then 60 would have been QD2 because obviously quantity demand falls. So just recognize we could have plugged these numbers in also and gotten a PED value. It would have. It's really we're doing the same thing, but sometimes the numbers are strange enough that I can't do it in my head, which is often. So I have to use this formula also to figure this out. All right, D, assuming no externalities, how does the tax affect allocative efficiency? This is a fairly stock question. Just understand that if there is a tax, right, we can see that there's some deadweight loss here. Again, deadweight loss, we define it as a loss of consumer surplus and producer surplus, right? It is the idea that society has lost some quantity here due to the tax. They can't afford it anymore. So we recognize and we can see that this deadweight loss triangle, we've lost this amount of consumer surplus and this amount of producer surplus. We have deadweight loss. If we have deadweight loss, we can't be allocatively efficient, right? So we would say, how does the tax affect allocative efficiency? I would just say due to the tax, there is deadweight loss. Therefore, society has lost some quantity of this good. And is not allocated efficient. And is not. That's kind of wordy. I'm sure the College Board actually made that one a little bit better than what I did. I think we have to mention the deadweight loss here. And just understand that consumer and producer surplus would have been maximized where that original supply and demand curve was. That would have been where we were allocatively efficient. Due to the losing of quantity to the tax, we have deadweight loss. We've lost some consumer surplus. We could also say that we've lost some total welfare. Society's worse off because of the tax, because they don't have that quantity of good. All right, guys, be safe. Thanks. Take care, and we'll see you soon.